Hey guys, welcome to my YouTube channel. Today we are going to see hypothesis testing part 2. Here we will be looking about t-test. We are having many hypothesis tests, but today we are going to see only about t-test, the entire thing about t-test. Let's go into the video. Hypothesis testing. The meaning is evaluate two mutual exclusive statements on a population using a sample data. Here we have null hypothesis and alternate hypothesis, which we saw in the previous video. Once again, let me explain. Null hypothesis is the statement which says there is no difference in the distribution, or the existing statement which is already been proposed. The alternate hypothesis is there is a difference, which means we are arguing that the existing statement is not right. It is totally different. So here we have null hypothesis and the alternate hypothesis, which is totally disagreeing the null hypothesis. And then there is an important term known as p-value, which is the significant value or alpha value. In simple, we could say the p-value as the probability value, which tells you how likely it is that your data could have occurred under the null hypothesis. We see a graph here. So this says the probability. The y-axis is of probability and the x-axis is of observed data. These are the two tails. The two tails are shown in blue color. This is a Gaussian distribution. So if we are having a 5% of data which is greater than or equal to 0.05, it falls in this range, in the mid range. The left side is 2.5 and right side is 2.5. In between the observed data is this place where we could find our p-value, which says the null hypothesis is right. If p-value is more than 0.5, we are having the data which says the null hypothesis is right. If we are having lesser than that or the condition changes, the p-value falls here in the tails, the both tails. So we are rejecting the null hypothesis and we are accepting the alternate hypothesis. So the step here is one, the initial assumption, that is the null hypothesis, which we have, which is already existing in the law. Second, we are collecting the evidence. Either we have to prove that null hypothesis is right, or we should say null hypothesis should be rejected and the alternate hypothesis should be accepted. That is the third step. Here we have the confusion matrix. Those who have gone through the classifiers have definitely known about this confusion matrix. So do not reject. This is the case. The null hypothesis should not be rejected. Here we are rejecting the null hypothesis through the evidence. We will see this type 1 and type 2 error in upcoming sessions. So now we are coming to this t-test. It is a type of inferential statistics which is used to determine if there is a significant difference between the mean of two groups which may be related in certain feature. That is, here we are going to see the difference between the mean. In different cases we will be having different criteria. We will be seeing it. The difference between the mean we are going to find through this t-test. Let's have an hands-on session. This is t-test, one sample t-test with Python. The t-test tells us whether the mean of the sample and the population are different. We are having t-test t equal to x bar minus mu, which is the mu is the proposed constant for the population. X is sample mean, x bar is sample mean, n is sample size, that is the number of observations, s is sample deviation, standard deviation, s x bar is estimated standard error of mean. We will be seeing it. One sample t-test, it is a statistical hypothesis test that can be used to see the mean of unknown population differs for given or known population. That is, see, we are having ages. I will run the code. Let's see the length. It's 30. We are going to see what is the mean of this age. We are having 30 data and we are going to see what is the mean of this data. We are importing numpy as np ages underscore mean. This is the variable which stores the mean of the ages. Let's print it. We are getting 31.066. So this is the mean. Now we are going to conduct a one sample t-test. That is, we are having only ages. In this ages column, we are going to just perform a t-test. We will use scipy.stats.t-test underscore one sample t-test. This is the thing, the one sample t-test we are going to use here. It is calculated for mean of one set of values. The null hypothesis is that the expected mean of a sample of independent observation is equal to specified population. That is, we are getting in a whole as 30 data, we are getting 31.066. If we take a random size of 10, a sample size of 10, and we are choosing the values randomly, and if we are seeing that means, see, we are taking the random ages, sorry, 10 values randomly chosen by np.random function. So we are getting 10 values. Now we are going to perform this t-test. We are going to see how it's gonna work. Now we are going to see this p-value. See, we are having 0.83. Its mean is 31.066. But after performing this test, we are getting 0.83. We are going to check the alpha value is 0.05 or less. So we are going to see that we are accepting all null hypothesis. So this is greater than 0.05. Next we are going to see two sample t-test. This test has another name as independent sample t-test. It is basically used to check whether the unknown population mean of given pair of the group is equal. It allows one to test null hypothesis that the mean of two groups are equal. We are having some assumptions here whether two sample data's group are independent. We have to check whether two groups are independent, whether the data element is respective of group, follow any normal distribution, and then whether the given two samples have similar variance. So these are the things we have to make assumption. Two sample t-test. Let us consider an example where two given sample data each contains a result of 10 students of a class. We need to choose whether two different class students have same height of mean. We have to see the mean here. So we have the syntax that as same, we are having data group 1, data group 2, and then equal var is true or false. By default equal var is true. So we are going to see that data group 1, it is a numpy array, and data group 2, see, we are seeing the variance here. Now we are going to perform this. Then we are going to check the p-value, p underscore value. So we are getting 0.83. So here also the null hypothesis is getting accepted, it is not getting rejected. Next we are going to see about paired t-test. Two variables which are, here we have two variables which are pre and post. Pre holds the score of student in maths before they are going to tuition, and then the post holds the score of students in maths after they are going to tuition. So we are having some 10 data here. We are going to perform this. We have done this. We are going to see that the paired samples t-test follows the null and alternate hypothesis, which says it is significant that mean pre-test and post-test scores are equal, and then it signifies that the mean pre-test and post-test are not equal. So if we are seeing this, I'm just copying these codes, we are accepting all null hypothesis. This is the analysis we have done using the t-test. We have seen one sample t-test, two sample t-test, and paired sample t-test. Stay tuned for next videos. We will be seeing chi-square test, ANOVA test, Z test, and etc. Thank you guys.